Hello guys, this is Wasim Malik, and this is our machine learning mini project, and our topic is Emojify using face recognition with machine learning. This is all the group members which we have combinedly worked in this project to completion of the for the completion of the project. In this presentation, in this project presentation, we will explore the use of face recognition machine learning to enhance the communication through Emojify. So let's discuss the how Emojify works. Emojify works by the analyzing the facial expressions using machine learning algorithms. It identifies the key facial features such as eyes and the eyes movement, mouth movement, and the eyebrows movement maps them according to the emoji. So it's have many benefits of emojis for the improvement engagement in market marketing. Doctors will also use it to understand the patient better. So let's directly jump into the project demo. This is our whole code, the main file which we are running over here. And by running, you have to click this add button. It contains three buttons. By clicking add button, you have to add the data. The added data means in this by the help of camera, by the help of video capturing, it will capture your facial expression to add the data. According like this, when you when you will when you will show your face and happy face, it will record it as a happy face. When you show your face as a sad face, it will record that as a sad face. As you can see, this is an emoji of angry. This is an emoji of good luck. This is an emoji of high. This is an emoji of happy. So this is all the things means you have to you have to make your facial expression like this so that you can add the data. So I've already added the data and already trained it. By clicking train button, you have to train it will train it itself. So and then after completion of the training, you have to click on run. By clicking on the run button, you have to a video will appear, a capturing video will appear. Oh yeah, you can say. So as we can see, it's properly working, and let's understand the code. I have stopped the video. I have stopped the output, and let's understand the code. It's a main. It's a main thing. It's a main file. This is a file. Basically, it's contained the UI video contained with three buttons: add data, train, and run. Each button associated with a specific function: data collection, training, and inference, respectively. But the detail of this function are not provided. As the provided, all the details has been provided in the code. The button have custom font settings for their labels and are organized in grid layout with a frame. When the UI is run, it will display three buttons. These buttons add data, train, and run. And then, as we can see, there is a training.python file. This code defines the Python for training a neural network model using a keras library. For this, first you have to import a necessary libraries like including NumPy, OS, OS, sys, and then keras. Then you have to define a function name training. Define a function training as a for training. Initialize variable and list data size is set to 100. Initialize it with a boolean variable set to false. List 1 y and dictionary d are initialized for storing data labels. Information account C to set 0. iterates through files in the current dictionary or current directory and identifies the file with the .npy extension. As we can see, it's a .npy extension. Okay, the data which are training, the data which collected, the place which the data getting stored over here, the extension as .npy. Extract the base name without the extension of this file. It's store it in a list. Okay, store it in a list. Map each label to unique index in the dictionary D. If if init is false, it loads the first .npy files in initialize the data array A and label array Y. Okay. For subsequent file, it concatenate the data to existing A array and add their corresponding label to the Y array. Convert the label convert the label in the Y array to one hot encoded using the two categorical functions. As you can see, the two categorical functions. Okay, concatenate that we and then let's get to the dictionary. Limit the two categorical function. Defines an input layer with a shape 1020 unit. Okay, and then add a dense layer with a 500 unit. Okay, as you can see that a dense layer 500 unit activation hyperbolic tangent 10h activation function. Add an output layer. Okay, add an output layer with the number of unit equal to the length of the label list L, sorry, list I. Using a softmax activation function, create a Keras model with the input and output layer and compile it with the Adam optimizer. Okay, compile it with the Adam optimizer. Print a summary of the model architecture. Fit the model to the training data A and Y for 100 epochs. For the 100 epochs, save the train model as model.h5 and label list as label.npy. It's basically the summary is that the code basically it's load the data from multiple .npy files, process and combines the data and label, trains a neural network model with a specific architecture and save the trained model as model.hy and the label list as labels.npy for future use in a machine learning task. The model architecture indicates a input layer, a hidden layer with a 500 units and 10h activation function, and an output layer with the softmax activation. The model is trained with categorical clause entropy loss and the Adam optimizer for 100 epochs. Let's go to the data collection section. From the start, for data collection section, basically this code capture video from webcam as we have shown that it's collect the data by webcam, detect facial and hand landmarks, hand hand gestures using the media pipe library, and collect the data for use in machine learning or computer vision tasks. The user is prompted to enter a data name, means we have to by clicking the button which we have seen in the PPT as I can show that the button is look like this. You have to click a button add data and then it's added the data and then you have to put the data name just like this. You have to put a data name just like I have given the happy. You have to put a data and then to save the collected data, the code continuously processes video frames, calculates the relative position of the facial and hand landmarks, and store the data as numpy array. It terminates data when the escape key is processed or after collecting 100 frames. It's totally collect the 100 frames. The data collected is saved as a .npy files with the specified data names. As you can see, the specified data names angry.npy, cool.npy, goodluck.npy. Okay, so the next is inference. The next is inference. Inference, what does it do? Means the code is the real-time inference using a pre-trained deep learning model to recognize hand and facial gestures and then overlay correspond to the emojis on the video feed. Here are summary also, and then it's basically you have to import necessary libraries including OpenCV, MediaPipe, NumPy, Kira, and Time. Okay, then we have to load the labels for gestures from labels.npy. Okay, the labels.npy, as we can see it's over here, the labels.npy file and the pre-trained deep learning model from the model.hpy file. Okay, as you can see it's over here, and then you have to capture a video from the default camera of your, maybe from your laptop, from your webcam. It can be anything. Initialize a media pipe solution for holistic means face means the holistic means it will be from face facial gestures. Holistic it, it might be from the face and hand landmarks with gestures, and sometimes it's only from hand. As for the like button, for the button like this, for good luck, sorry. So the next thing is enter an infinity loop, and an infinite loop to continuously process video frames up till and we have up till we exit the with exe escape button. For each frame it does following: read a frame from the camera and flip it the horizontal to avoid a mirror effect. Using this holistic model to detect, okay, using this holistic model to detect, basically it's detect using holistic models to detect and draw facial and hand landmarks on the frames. Landmarks means the facial expression, hand gestures on the frame. Calculate the relative position of the facial and hand landmarks similar to the data collection code. So we have to measure the frames, and it's basically measure the frames per second. It's the FPS and display to the top left corner of the frame, which we have seen, which we are, and you can see it's basically it's calculating the frame 9, sometimes it's 7, and sometimes it's 5, sometimes it's 9, depend on the FPS rate. So it's calculate the FPS. Okay, then basically it's try to load and display an emoji image based on the predicted label. Emoji image are expected to be stored in the emoji directory and name after the corresponding labels. Continually display the video feed with annotation with emoji until the escape key button is pressed. Okay, as you can see, this is the predicted emojis. These are the predicted emojis. These are the predicted emojis. So then release the camera, close the OpenCV window, and exit the inference loop. Basically, in small words, this could capture video from webcam, detect hand and facial landmarks, use a pre-trained machine learning model to recognize gestures, and overlay corresponding emojis based on the recognized gesture in real time. It also displays the FPS. FPS, as you can see, it also displays the FPS. Also created a block diagram. Basically, it's over here. As you can see, it's a block diagram basically showing the start button, input data. It's basically filter to remove noise. It's making decision. If yes, then analyze based on the facial parameters. If no, then it takes the data. It converts the emoji input image, means we have the input image into the cartoon image. Okay, then output image cartoon image similar to emojis. The cartoon image will be similar to emojis, and then it will end the program. Okay, so it's have many applications related to marketing. Emoji for collection of in marketing, in education, in healthcare, and this is all the things which we have shown in the demo. And We came to our end of the presentation. Emoji is a very powerful technology with the potential to enhance communication in various ways. Where there are challenges to consider, the benefit of emojis are numerous. There are many benefits of emojis. We hope the presentation has inspired you to explore possibilities of emoji and consider potential impact on our life and on our work. Thank you for watching our video.